So, trig ratios day one. This is my plan. I'm going to go for 30 minutes. Okay, we'll see how far I go. May go for 25 because I want to leave y'all time to get started on your assignment before you leave this building. If you don't turn it in on Monday, it's a 0, and I will not accept it late. It's all or nothing, folks. Okay, is that fair enough? I'm telling you now, it's all or nothing. All right, so you got to get it done. The worksheet I'm gonna give you in a little bit. Here we go. Trig ratios. Now the angle-angle similarity postulate, you end up having right triangles that are similar to one another, okay? Now, because they are similar, we're able to set up these ratios based upon these sides of the right triangles. It says these are trigonometric ratios. A trig ratio, because that's what we're going to call them, is a ratio of two sides of a right triangle. Okay? Trig ratio is a ratio of two sides of a right triangle. Now, you can only use trig ratios with right triangles. It's the only kind of triangle this will work on. Okay? These right triangles have two acute angles that are not special, meaning they're not 45, 45, 90, they're not 30, 60, 90, but they might be something like 21, no, hold on, 69, 90 triangles. Or they might be something like 34, 56, 90 triangles. You know, because the special right triangles are they're easy ones to remember. 45, 45, 90, 30, 60, 90. These are going to be some messed up acute angles. Okay? Now, don't turn me off yet. I ain't even got started good. Now, but when you see these odd-looking acute angles, the ones that are not our typical 45, 45, 90, 30, 60, 90, you're going to a bell should ring in your head going, "Oop, this is trig ratios." Okay? These ratios allow us to find each side length of that triangle, meaning the shorter leg, the longer leg, and the hypotenuse. So we'll be able to find every side of the triangle that you're given. Okay? Now the actual trig ratios. You have that, right? Okay. Let's say that I give you this angle right here. That's the angle given. We'll call this triangle A, B, C. Be sure you label your triangle the same way I label mine. The one side in a right triangle that never changes, it is the same place every time, every right triangle is the hypotenuse. Why? Because it's always across from the right angle. So the hypotenuse is always in the same location. Well, right, but if it doesn't matter where that right angle is located, if you go straight across from it, that's your hypotenuse. Do you guys agree? Now, with relation to this angle A, we've got two other sides we got to worry about. Where is the side opposite angle A, that angle that I circled? Be very specific. BC is the side opposite the given angle. Give me the side that's opposite that angle that I circled, that angle A. That means that whatever's left over is called the adjacent side. Do you remember what adjacent means? Next to, side by side. Okay? So now, notice how I labeled that triangle. I labeled the hypotenuse first, and then I labeled the what? Opposite, and then I labeled the what last? The adjacent. And I do it in that order every single time. Here we go. What are these ratios? Ratio is just a fancy word for what? Fraction. Sine ratio is this. Opposite over hypotenuse. Write these down. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. I want you to look at that. Write that down for me. Here we go. Some old horse. This is stupid, but it will. Shut your face. It will help you remember. Some old horse caught a horse taking oats away. Does that make any sense at all? Nope, it doesn't, but it's kind of crazy, and you will remember it. However, remember, the order is always the same, sine, cosine, tangent. I was taught this. Oscar has a heap of apples. Y'all, I will be up here working a problem. Oscar has a heap of apples. That is so nonsense. Who gives a crap about Oscar? I don't care what he's got a heap of. I do not care, but I remember that from high school. Okay? And I'll be up here working a problem, and you will hear me go, Oscar has a heap. Or you'll see me go through it in my mind, dun, 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 and then I'll lock into the right ratio. But folks, if you learn that saying, look, are you having to memorize anything? No. Because when I say old horse, it's going to make you think of what? Opposite over hypotenuse. When I say, see, I got to think about it, oats away, what's it going to make you think of? Opposite over adjacent. So you're not memorizing anything. Now, how am I going to use this? This is how you're going to use it. Beautiful graphic, gorgeous, absolutely beautiful. Things to remember. Take your calculator. Your calculators have to be in degree mode. Hit the mode button at the top of your calculator, and you should see normal, float, radian. Do you see the line that says radian? It says normal, float, radian. Do you see radian? And if you go to the side, to the right, you want to highlight degree and hit enter. If your calculator is not in degree mode, you're going to get the wrong answers. Okay? Now, if the black box is on degree, yeah, right there's the stack. You'll have to find, no, right there, you'll have to find yours, okay? You will have to be sure that degree is highlighted or boxed. Now, if you hit enter, how are you going to get back to the home screen? Hit second mode. That takes you back to the home screen, okay? Everybody cool with that? All right, so degree mode, degree mode, degree mode, degree mode. How to solve the problems. Here are the steps that you're going to follow every single time, okay? You're going to circle the acute angle given. Do y'all remember how I circled that in that big triangle? I circled, circled, circled. You're going to do that every time, okay? The second thing you're going to do, you're going to label all sides of the triangle. Okay? Next thing you're going to do is you're going to write all of your ratios beside the problem. This is what I said. You're going to think it's a lot. It's really not a lot. And then you're going to ask yourself, go ahead. you're going to ask yourself, which side do I know absolutely nothing about? Ask yourself, which side do I know absolutely nothing about? And then you're going to set up your ratios. And then you're going to solve your proportion. All it is solving a proportion, folks. That's all. Okay? So we're going to circle the acute angle. We're going to label the sides of the triangle. You're going to write your ratios beside the problem. You're going to set up your ratios, and then you're going to solve. Okay? Every single problem. Okay? Sounds like a lot, doesn't it? It's really not. All right, now, just before we start doing any of that, I want you to take your calculator, because you got to figure out how to use your calculator, and I want you to find cosine of 23 degrees. Now, literally, all you're going to do is you're going to click on the cosine button, and then you're going to hit, what was it, 23 degrees? Click on 23 degrees. And then hit enter. And you're going to get this big old decimal. Okay?
Because I got the degree from the dinner.
All right, you just hit second quit.
Second.
Yep.
Yeah, but what do you have like?
It's in degrees.
Yeah,
Function. Now second quit. All right, here we go. Cosine of 23. Hey, is my calculator in the right mode? Yeah, okay, second quit. Cosine of 23. Ooh-wee. 4 decimal places here, y'all. Oh, it says round to the nearest tenth, doesn't it? How you going to round that to the nearest tenth? 0.9. It's approximately 0.9. All right, find the tangent of 82. Do that now. You don't need me to take you through that. Tangent of 82 degrees. And you round it to the tenths place. Tenths. All right, look, it's 7.11 blah, 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 right? Where's the tenths place? The first one after the decimal. What's this 1 going to do to that 1? It's going to do nothing to it, so it's going to be 7.1. Okay? Is that easy? Yeah, that's easy. All right, so let's just take another. We're taking baby steps here, okay? Now, this example 3 says we got to label our triangle sides. Remember, you're going to be given this off acute angle, right? This one, it doesn't look right. So which one is my weird looking acute angle? 23 degrees, isn't it? Right? Circle it. What's the first side we always label in our right triangle? The hypotenuse, which is always across from the right angle, the 90-degree angle. Now, with relation to that angle that we just circled, where is the opposite side? Is it on the upright side or the bottom? Let me ask it again. Hold on and listen to what I'm asking. Where is the side opposite the angle that I circled? Is it at the bottom or the upright? It's at the bottom, y'all. If you were standing here in this corner and you shot a bow and arrow, where would it go? Boom. That's the opposite side. No, I kept saying, with respect to the angle I circled, your opposite side is across from the angle that I circled. That means, no, it's not. Shut your face. What's the leftover side have to be? Adjacent. It's all going to come together here in just a second. On my desk. All right, let's do the next one. What am I going to circle in the second? That's all I want to do is just label it. Label 18. What's the first side of the triangle I'm going to label? Hypotenuse, which is always across from the... Which side's the opposite? The upright or the bottom? Upright. There we go. Which means the bottom has to be the what? Okay, y'all rocking and rolling now? Not so difficult, right? Okay. Right, Joseph? How come? Did you circle your angle? Okay. If you circle your angle, you know your hypotenuse is across from the right angle, correct? You know that. That's a given.
I don't know how to choose which one is opposite what I do.
Okay. Imagine yourself in this corner right here with the 23-degree angle. If you are shooting a bow and arrow, okay? If you're shooting a gun, if you're throwing ninja stars, if you're kicking a kickball, if you're throwing a football, where are you going to throw that football? What side of that triangle is it going to hit? It better hit which side, or you're going to be running. It better hit the opposite. Boom. That's the opposite. The one left over is the adjacent. Okay? Always, always, always. Now, oh, here we go. Here's the straight up problem, okay? Now look. What are we finding? We're finding x. Where is the acute angle? Folks, this is exactly what we're going to do every single time. Where is the acute angle that we're going to circle? Circle it. What's the next thing we got to do? We got to label our triangle. So label the hypotenuse. Woo-wee, hold on now. The opposite is at the bottom, right? That means the adjacent's what's left over, correct? Listen. Y'all with me? Yeah. All right, over here, every problem, I want you to do this. Some old horse caught a horse taking oats away. This is what's going to make your life nice, okay? Some old horse caught a horse taking oats away. I have just written the ratios above, and we're going to do it every problem, okay? Now, let me ask you something. Shh. Yes, here we go. Check this out. Which side? The next step. Ask yourself, which side do we know absolutely nothing about? Why? Because it's not marked with anything. It doesn't have a number. It doesn't have a variable. It has nothing. Mark it out. If I mark out A here, I'm going to come over here to my ratios, and everywhere I see an A, I'm going to mark it out. Boom, boom. Which ratio do we have to use? I'll be John Brown. Looky there. Now, when we eliminate, it tells us which one to use. This is what we're going to use. Sine of, what's the angle we circled? 37 degrees. And you're going to write it over 1. Over 1. Can I write anything over 1 and it'll never change its value? Okay? No, don't care about the degree sign. If you want to put it there, you put it there. I don't really give a hind, don't care. Don't care. Opposite over hypotenuse. What's my opposite side? X. What's my hypotenuse? Do I have a proportion? Can I cross multiply this and solve? I sure can. Check this out. Check it out. Check it out. Sine of 37 times 14 is equal to x times 1. Yep. Why do I have to put the sign in there? Because we have to find the sine of that angle. That's just part of it. We got to do it. Okay? Now, hold up. Put in your calculator. You're welcome. Sine of 37. Did that thing go off already? Dag nabbit. Y'all's do. Mine's run out of batteries. I just said that's a lie. It doesn't have batteries. I hate when that happens. All right, you ready? All right, here we go. Take your calculator and press, don't hit, sine of 37, enter. Wait a minute. We're going to multiply that number times what? Times 14. Now, we're going to write that number down. 8.425. And we're going to go dot, dot, dot. What's x times 1? 1x or x. Hey, do we have a value? Yes. What does it say? Round your answer to the nearest tenths place. So x is approximately 8.4. You just found your first side of a right triangle. You just did trig. That is easy, isn't it? Now, I told you, it's a lot of prep work. But if you do the prep work, you're going to get the problems right every single time.
So we're always going to mark out adjacent.
No, you're always going to mark out which side? The one that we don't know doodly squat about. Not necessarily. Look at your next problem. Okay? Right triangle. What's the first thing we circle? 40. What's the first side we label? Hypotenuse, which is what? X. It's at the top, isn't it? And then, thank you, what's this other side right here? 13 is adjacent. Uh-oh. Just a different formula. Hey, what do we have to write up here to the side? Or up at the top? Some old horse taught a horse taking oats away. Write it every single time.
Why do you write it with the letters on?
It's a good question. Why do I write the S, the C, and the T big? Because that's sine, cosine, and tangent. And that represents opposite over hypotenuse, adjacent over hypotenuse. And I'm just not drawing the fraction bar. Okay? Pardon me? No, I did not. All right, so here we go. Opposites of one. Why do we mark that one out? Because I don't know anything about it, so mark it out. So if I mark the O out over here on the triangle, what do I come over here and mark out? Everything that has an O. Oh! So I guess I use which one? Sine, cosine, or tangent? Cosine of who? Cosine of who? 40, the one I circled. Over who? 1 is equal to. One more time. 13 over x. Right on. Your adjacent is 13. Your hypotenuse is x. Very good. Very good. Okay? Chill. Chill. Cross multiply. Cosine 40 times x is equal to 1 times 13, which is 13. Do you guys agree with that? Yeah? All right, how am I going to get x by itself? Ooh, divide by what? Divide by who? Cosine of 40. All right, check this out. My cosines cancel on the left side, do they not? All right, that leaves me with x is equal to something. Get your calculator. All right, now, folks, you got to be a parentheses ninja. If you're not, it will not work out. 13 divided by parentheses. Cosine 40, close the parentheses. I'm going to close it again because I'm closing the 40 and then I close the cosine of 40, okay? Hit enter. What's the length of that side? 16 point, hold that thought, 0.97 something, 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 right? And then I have to round it to approximately 17. Is this facile or difficile? I see. Comme ci, comme ça? Okay. Let's do another one. We're not going to give up. We're going to keep working. What are we going to circle? 21. What next? Hypotenuse label. Woo! Where's your opposite side this time? Why? And then what? That's right. Don't know nothing about the. Oh, wait, though. Some old horse caught a horse. Take oats away. And you're right, I don't know anything about the hypotenuse. I'm going to mark it out. What's that mean I mark out up there? The first two, don't I? Oh, I guess I have to use what? The other one, the tangent. And it's going to be tangent of who? 21 over who? Is equal to, what's the opposite? Over 25. Y'all with me? Any questions at all? Why are we using tangent, y'all? Because it's at the T, and what do we not know anything about? I don't know anything about the hypotenuse. So if I mark it out here, Justin, then I mark it out here, and I mark it out here, because that's where my H's are. Okay? All right, so calculator. In a minute. Tangent of 21 times who is equal to who? Do you guys see what we're doing? Now calculator. Tangent of 21, enter. You tell me. Times 25, enter. What's the length of this? 9.6, y'all? It's approximately 9.6. You just put what? Sometimes it is, but if you're dividing, if you ever have to divide and you don't hit the enter in between, the calculator's going to recognize the order of operations, and it may multiply the wrong two numbers together or divide the wrong two numbers together. So that's why I take it chunk by chunk. Okay? I'd rather err on the side of punching too many buttons than not punching enough and getting the wrong answer. Okay? What do you think? All right. Ooh. UK, all right, because that one's marked off. All right, do this one for me.
How do you get 9.6? How do you put that calculator?
Well, it was 9.59, right?
No, when you got 10
I just put in tangent 21 and I hit enter. And then I multiplied that answer by 25, and that's how I got 9.6. Okay? Hey, right now, here's what you're going to have to do. Okay? All right, so for homework, you got this 575881. It's going to be a take-home quiz. Okay? That means you can use your notes, you can use your book, you can use the internet. You should not use each other, but I'm not crazy enough to think y'all won't be on the phone or on the internet or whatever. Okay? Now, the thing is, been there, done that, y'all. Been there, done that. Thing is, you got to show your work. Now, you're going to do what you got to do. But if I do not receive this on Monday, it's a 0. It's all or nothing. Do I make myself clear? A 0 for a quiz, that's right. Okay? It's due for a grade. And I would definitely take my book with me. Sections 5, 7, 5, 8, and 8.1. Might see some examples in your book that are similar to this. Okay? The next thing I want you to do, if you look at the last page of your notes, those examples You got 6 examples. I want you to do that. Now, typically, I don't give you this much homework. You got 3 days. Suck it up. Tonight, tomorrow, Sunday. All day Monday, you technically have 3.5, almost 4 days, because some of you will wait until lunch on Monday. Some of you will wait till Sunday night. That's cool. You got to do what you got to do. However, this is due for grade on Monday, no questions asked. Do you understand? Okay? If you have questions on Monday morning, where should I see you? I should see you in here in the morning. Y'all know I got bus duty downstairs, so I don't get in here. Usually it's 8:10. By the time I walk downstairs, sign in, and then walk back or come back up here. Okay?